Rock, paper, scissors is a hand game which is played by two people. The mechanics of the game is for both players to choose a shape simultaneously and form one of the three shapes which will be portrayed by their hands. The player can choose between the shapes of a rock, paper, or a scissor. The rule is simple. A player who decides to play rock will beat a player who plays scissors. But if the player chooses paper against a rock, paper will win. However, a play of scissors will win against a paper. Lastly, if both players came up with both shapes, such as a rock against a rock, the round will end up as a tie and players will have to replay the round. The game Rock, Paper, Scissors is considered a fair game, similar to a coin flip where both sides play in order to settle a dispute or a decision. Usually, both players come up with points to determine the winner, and once a player reaches the agreed score made by both players, he or she will emerge victorious.
Now, for our circuit, we used a total of 4 inputs, 2 for player 1 and another 2 for player 2. The gates that were used are AND 7408 or 7432, SOR 7486, and NOT 7404 ICs. As you can observe, there are only 4 inputs. This is to lessen the ICs and gates to be used in the circuit. Also, this is to bypass the problem encountered when 6 inputs are used. For example, choosing 2 out of 3 choices. The choice may be paper and rock or rock and scissors. The output will be incorrect since you only need to choose one of the 3. So if you choose more than one, the LEDs will either not work or the LEDs will all light up at the same time. To further explain, our circuit has 4 parts. But before that, we have to note that 01 is for paper, 10 is for rock, and 11 is for scissors. The first part of our circuit is to know if player 1 won the game or not. In this section, there is a total of 11 gates. These are 4 NOT gates, 5 AND gates, 1 SOR gate, and 1 OR gate. The equation that we use to achieve the final output is A0 BCD0 plus AD multiplied to the output of the SOR gate with inputs B and C. The second part of our circuit is to know if player 2 won the game or not. In this section, there are a total of 7 gates. These are 5 AND gates, 1 SOR gate, and 1 OR gate. The equation that we use to achieve the final output is AB0 C0 D plus BC multiplied to the output of the SOR gate with inputs A and D.
In the third part, this section determines whether the inputs will output a tie result. In order to determine whether the inputs are tied, the input will undergo certain gates, specifically an OR gate, SOR gate, NOT gate, and AND gate. Since XNOR is not an option to be used in this project, we improvised and used a SOR gate and connected it to NOT gate in order to achieve an XNOR gate. Overall, the circuit for tie used 1 OR gate, 2 SOR gates, 2 NOT gates, and 2 AND gates. And to achieve the final output for this section, we use the equation A plus B times the output of both XNOR gates of BD and AC. Lastly, this section shows the choice made by both players, whether it is a rock, paper, or a scissor. For example, player 1 decides to play a rock. The equation made by the circuit is A not B multiplied to C plus D. And if player 2 decides to play paper, the equation is CD multiplied to A plus B. In addition, the LED lights will remain off when there is no decision made yet by one of the players. Overall, this section has a total of 2 OR gates and 12 AND gates. So now, let's play the game. If player 1 picks a rock and player 2 picks a rock, the result is tie. If player 1 picks a rock and player 2 picks paper, the result will be player 2 wins. If player 1 picks paper and player 2 picks a rock, player 1 will win. If player 1 picks paper and player 2 picks paper, the result is tie. If player 1 picks scissors and player 2 picks rock, player 2 wins. If player 1 picks scissors and player 2 picks a paper, player 1 wins. So if both players pick scissors, the result is tie.
Here's the isometric projection of our rock, paper, scissors circuit model or UI design. The top view of the model shows 9 LEDs. 6 LEDs are used for showing whether players 1 and 2 chose rock, paper, or scissors. The remaining 3 LEDs are used to show who won the game or if the game ended up in a tie. As we can see, there is also a provided instruction for the players so that they know how to play the game. Press left button for rock, press right button for paper, and press both buttons at the same time for scissors. Continuing to the side view of our model, we can see the labels rock, paper, and scissors, alongside the 2 buttons the players need to press. Overall, our circuit model has a symmetrical design to it, with a color scheme of black, white, and yellow. The LEDs are placed in such a way that the player can easily see what the other player chose after pressing the buttons, whether it might be paper, scissors, or rock. On the other hand, the 3 LEDs in the center of the circuit shows if player 1 or player 2 won the game, or if the game is tied. Rock, paper, and scissors is a unique and fair game. The game is so simple to grasp that all players can easily understand the rules completely. Lastly, the game does not favor anybody, and it can only be won by chance or thinking strategically. That is all for our video presentation. Thank you for watching.